2.2, we are going to take a look at solving some equations, and then we are going to refresh graphing, just keep that fresh, and then we will be working on solving systems using substitution. Today we are going to be solving for one variable in 2.2, and then down the line we're going to solve for both variables. That's the end goal. Just a couple equations to keep us fresh on two-step equations. We are working on getting b by itself. In order to get b by itself, I need to move both the 3 and the 4. The 4 is attached to the b by division, so we are going to take care of that second. The first thing we're going to take care of is this 3 that is subtracting. We get rid of a 3 that is subtracting by adding. So we do the inverse operation. Those cancel out, and we have b divided by 4 is equal to 1. b divided by 4, we need to get rid of divided by 4 by doing the inverse, or the opposite. The opposite of division is multiplication. So we multiply 4 to both sides, that cancels it out. And then b is equal to 1 times 4, which is 4. Number 2, we need to get x by itself, which means we need to move the negative 8 and this negative 4 that is multiplying with x. So because negative 4 is attached to the x, we are going to take care of that second. The first thing we're going to take care of is this negative 8. We get rid of a negative 8 by adding it to both sides. This gives us negative 4x is equal to, signs are different, so we will subtract and keep the sign of the larger number, negative 56. Negative 4 is multiplying with x. To undo multiplication, we will divide. And that will leave us with x is equal to, a negative divided by a negative will give us a positive 16. 56 divided by 4. I'm sorry, 14. Okay, numbers 3 and 4 are important for what we are going to be doing today. We will be working with multi-step equations when solving using substitution, and this is some practice on those before we move into actually substituting. So I'm going to distribute 3 times 2n to get 6n, and 3 times 3 to get 9. I'm going to bring down the rest of my equation that hasn't changed. Now I'm looking for like terms to combine. I have a like term of n's, which I will highlight in blue. I have 6n and 3n, so I'm just going to gather those up together to have 9n plus 9, which came from here, equals 54. Now we have a two-step equation, just like we worked on in numbers 1 and 2. I will subtract 9 from both sides to get 45, and these cancel out. 9n I rewrite, and then I divide 9 to both sides to get rid of this, to leave n by itself, and 45 divided by 9 is 5, so n equals 5. Okay, and number 4, I'm distributing a negative 5 in, so a negative 5 times 1 is negative 5, and a negative 5 times 4p is negative 20p. I continue to rewrite the rest of my equation. Minus 4p equals negative 77. If it helps, we'll split this into 2 obvious sides. Okay, the next thing I'm looking to do, which I'll highlight in blue, is combine like terms. I have a like term of negative 20p and negative 4p. If I count those up, I end up with negative 24p. And then I rewrite the rest. So negative 5 minus 24p. If you notice, this negative 24 is attached to the p. So we take care of that last. The first thing we need to take care of is this negative 5. We get rid of a negative 5 by adding it to both sides. I'll rewrite negative 24p equals negative 77 plus 5 will give us a negative 72. Signs are different, so we subtract and keep the sign of the larger number. From here, I'm dividing negative 24 to both sides. Those cancel out so that p is left by itself, and it equals a negative 72 divided by a negative 24. Our signs are the same, and because they're the same, we will get a positive answer, and then we are working with 72 divided by 24, which will give us 3. So it's positive 3. All right, I'm going to briefly graph these. I'm not going to write the M or the B for these. We should be able to look at this and identify. If you need to write the M and B down, great. It's not a bad thing, but I'm just, for the sake of time, not going to do that. So we are beginning at negative 4. That's our B value, and y equals mx plus b. And we are moving up 8, right 3. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Put a point. Connect my points very, very poorly. It's a little bit better. In red, I am beginning at 2 and moving up to right 3. So for my red equation, I am beginning at 2 and then counting up to right 3. 1, 2, 1, 2, 3. I could also count down to left 3. And draw a line through there. And our solution is where our red and our blue cross to make purple. And we describe our solution as an ordered pair, x comma y. Our x value is 3, and our y value is 4. So 3 comma 4. All right, same thing with number 6. So I'm going to begin at 1, and I'm going to count up to right 3. I could also count down to and left 3. In red, I'm going to begin at negative 3, and I'm counting down to, because of this negative, I'm counting down to right 3. So I'm going to go down to right 3. I can also do the exact opposite and go up to left 3. And where my red and blue cross, that is my solution to these system of equations. So I'm going to describe it as my x value, which is negative 3, comma my y value, which is negative 1. Okay, we're going to solve each system by substitution. Eventually, we're looking for an ordered pair, an x comma y, an x value and a y value. For 2.2, we are just going to be looking for to solve one variable, and then we will solve the other variable in future lessons. So here's what I'm going to do. I'm going to take what y equals, which is negative 4x minus 2, and I'm going to replace it for y. I'm going to substitute with parentheses negative 4x minus 2 in my other equation. Then I'm going to complete writing my equation out, equals 1. Okay, now I have a multi-step equation. I'm going to begin by distributing this negative. It's really a negative 1, but what a negative sign means is the opposite of. So I'll do this in purple so we see. The opposite of negative 4 is positive 4x. The opposite of negative 2 is positive 2. And I used up my negative sign, so I'm going to rewrite my negative 3x. And I'm going to rewrite my equals 1. All right. My next step is to combine like terms. 3x and 4x are like terms, and they make signs are different, so we will subtract and keep the sign of the larger number to get positive 1x plus 2 equals 1. Now I didn't write 1x because it means the same thing as x. And then we would subtract 2 to both sides. Oops, I don't know what I decided to do there. And then x is equal to negative 1. All right, continuing on with number 8, same idea. So now we are not only substituting, but we are actually solving out to find one of our values. So this is the same kind of idea. We have 4x minus, and then instead of y, I'm replacing it with negative 5x minus 9. And then we set that equal to negative 18. I start with distribution. Remember, if we just have a negative there, it means the opposite of. So the opposite of negative 5x, positive 5x. The opposite of negative 9, positive 9. And then I'm going to rewrite the rest of the equation. So 4x equals negative 18. Like terms get put together, which in this case would be a positive 4x and a positive 5x, which is actually 9x. We count those up. Plus 9 equals negative 18. I now have a two-step equation. I'm subtracting 9 from both sides first, which means 9x equals negative 27. And then I'm dividing 9 from both sides to find that our value of x is negative 3. Negative 27 divided by 9, negative 3. This is just the first half. We would then have to take our x value and plug it back in, but we will be doing that in future lessons. All right, let's take a look here at number 9. We have y is equal to 4x minus 1. So in my other equation, 2x plus 3, and then I'm replacing the y. I'm substituting it with 4x minus 1 equals negative 3. I am distributing in. 3 times 4 is 12x. 3 times negative 1 is negative 3. Everything else gets rewritten. So that's 2x and negative 3. Notice that I'm not rewriting this 3 down here because I used it up when I made the 12 and the negative 3. I used it up when I distributed. I combine like terms. That's going to give me 14x minus 3 equals negative 3. I then add 3 to both sides. So 14x equals 0. So as long as we know our inverse operations, if we can tell what's opposite of addition and what's opposite of multiplication, and we do it in the right order, we can solve equations. So in this one, x equals 0 because negative 3 plus 3 is 0, and then I divide 14 to both sides. Okay, in our last example, we're taking 5x plus 16 and plugging it in for y. So over here, I'm taking 3x minus 6, and then instead of y, I'm replacing it. I'm substituting in 5x plus 16. equals 12. In this one, I'm taking this negative 6 and distributing it in, so negative 6 times 5x, I'll write that there, and negative 6 times 16, which I'm probably going to need a calculator to figure out, but that's okay. So for my blue, negative 6 times 5, I'm going to get negative 30x. For my purple, negative 6 times 16, I'm going to get negative 96. Look at me go. I didn't even use a calculator. It's probably wrong. Oh well. And then 3x. I could double check, but I'm pretty confident. 6 times 6 is 36. Carry my 3. 6 times 1 is 6. 7, 8, 9, 96. Okay. Now I'm putting my like terms together, which would be these two, which is going to give me negative 27x minus 96 equals 12. Some big nasty numbers, but the process doesn't change. So I'm adding 96 to both sides. That's going to give me 108 equals negative 27x. And when I divide negative 27 to both sides to get x by itself, so even though these are large numbers, the process is still the same. If we were using 1s and 2s, or if we're using 108 and 27, the process is still the same. And x equals negative 4. So 108 divided by 27 is negative 4, divided by negative 27, I should say. All right, next time we will work on finding our other variables. So in this one, when we plug in and substitute for y, we're able to find our x value. Next time we will take that x value and plug it back in so that we can solve for y as well and be left with an ordered pair, which is what our answer is always written as in a system of equations.